Hello, so today we're going to be talking about arithmetic sequences. Now, a sequence is a set of numbers in a specific order. If the order happens to be always increasing or decreasing by the same value from one number to the next, is what we call an arithmetic sequence. And by increasing or decreasing by the same value, I mean we're always adding 4, adding 5, subtracting 7, whatever it is, with each and every set of numbers. If we're not doing that, then we might still have a sequence, but it might not be it won't be an arithmetic sequence. There are geometric sequences. We'll discuss that at a later date, and there are other types of sequences that depend upon the types of numbers you're dealing with. So we're going to determine whether each one of these sequences is an arithmetic sequence. So -4, -2, 0, 2. So to go from -4 to -2, we have to add 2. To go from -2 to 0, we have to add 2. To go to 0 to 2, we have to add 2. So we're adding the same number for each one of these. This is, yes, that is an arithmetic sequence. For this one, 1, 1, 2, 3, 0, 5. So we have to add 0 there, plus 1, plus 1, plus 2. As you can see, we're not increasing by the same number. So this is not an arithmetic sequence. It is still a sequence. These are the first 5 digits of a Fibonacci sequence. The Fibonacci sequence is when you add the previous 2 terms to get the next one. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and then so on down the list. That sequence was featured in a lot in the movie and the book, Da Vinci Code. This next one, we have -26, -22, -18, -14. And for each one of these, we are adding 4 to get to the next number. Because I'm adding the same number over and over again, this is an arithmetic sequence. And then this last one, well, I have to add 3 to get to 4. I have to add 5 to get to 9, 7 to get to 16, and then 9 to get to 25. So this is not an arithmetic sequence. We're not adding the same number each and every time. However, this is a sequence of all those perfect squares starting with 1. So 1, 4, 9, 16, 25, and so on down the list. You can also consider this as you're always adding on the next odd numbers. We add by 3, so then 5, 7, 9, 11, 13, so on. That's just one of the interesting properties of our perfect squares. So those are all, so 1 and 3 are both arithmetic sequences, 2 and 4 are both types of sequences, but not an arithmetic sequence. Now, arithmetic sequence is one that we can write in this form, where n is our nth term. So the nth term of an arithmetic sequence, with the first term is given by a1. Your common difference, that's what we increase or decrease by, is your d value. So we're going to use this general equation right here to write our equations of these sequences. So for all the future problems, they will be an arithmetic sequence. So you don't have to worry about, well, are they or are they not? They will be. The key is finding what the d value is, what is your first term, and stuff like that. So we want to write our equation for these sequences. So -12, -8, -4, 0. So to write an equation, we need to identify what our first term is, which is -12. And we need to identify our common difference. To go from -12 to -8, I have to add 4. Since I'm increasing, our d value is a positive 4. Now I have everything I need. So I'm going to plug back into our equation. an equals a1 plus n minus 1 times d. We don't know n in this case. We're just talking about in general the nth term. So when I distribute the 4, we'll have -12 plus 4n minus 4. 4 times n, 4 times -1. And when I combine my -12 and my -4, we get an equals 4n minus 16. Make sure your n comes first. Proper way of writing an equation. So there's the arithmetic sequence that would govern this sequence right here. Way to check yourself out. 0 is supposed to be the 4th term. If I plug in 4 for n, I better get 0. Well, 4 times 4 is 16. 16 minus 16 is 0. It checks out. So for future problems, we're going to use these equations we write to find, like, for example, what is the 75th term in the sequence? We could theoretically just keep on adding 4 until we get to the correct number, but that would be really, 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 really long and tedious. It is better to first write the equation and then plug in the n value we want. We'll get to that later. Alright, this one, we have 3, negative 10, negative 23, negative 36. So I still need to identify my first term, which is 3. And now I need to find my common difference. Well, to go from 3 to negative 10, I have to subtract by 13. Since I'm subtracting, I'm getting smaller, the difference is a negative number. So that's why it's negative 13 for my common difference. So now I plug both those values into my equation. So an equals a1 plus n minus 1 times our d, negative 13. When I distribute the negative 13, we'll have 3 minus 13n plus 13. And then when I combine like terms, 3 plus 13 is 16. So my equation, an equals negative 13n plus 16. And again, you can plug in 1, 2, 3, 4 for n to verify you're having those same points if you wanted to. No need. Alright, so you should go ahead and try this one out on your own. Yes, there are decimals, but the process is still the exact same. Identify your first term, identify your common difference, write your equation. So again, pause the video while you work that one out. Alright, so your equation should be an equals 1.3n plus 5.9. We're increasing by 1.3, that's why our d value is positive 1.3, and then when we combine like terms, that's what we're getting. Okay, so now we want to find the first term in the sequence given some nth term, like the 8th term, the 12th term, the 57th term, and the common difference. So we're given a7 equals 13 and d equals 4. So this tells us our 7th term is 13, which means n is 7. We're going to use all this to plug back into that equation, where we'll find every single thing except for a1 is known. So again, our equation was an, so in this case it would be a7, so it's 13, equals a1, we don't know it, plus n minus 1, since n is 7, it'll be 7 minus 1, times our common difference of 4. So 13 equals a1 plus 6 times 4, which is 13 equals a1 plus 24. So I subtract 24 from both sides, we get negative 11 for a1. So for this particular sequence that has a common difference of 4, 7th term is 13, my first term would have had to have been negative 11. There we go. So finding your first term is very similar to writing your equations. The difference is you're going to plug in for an, n, and d, and solve for a1. And this value right here tells you what n is. So a19 is negative 38. Our common difference is negative 2. We want to find our first term. Since we're referring to a19, our nth term is 19. So a19, so negative 38, equals a1 plus n minus 1 times d. So we have negative 38 equals a1 plus 18 times negative 2, which means we have negative 38 equals a1 minus 36. And when I add 36 to both sides, we will get a negative 2 for our a1 value, which means our first term in this particular sequence was negative 2. So we started at negative 2 and decreased by 2 for every single step of the way. Alright, so I want you to go ahead and give this problem a shot on your own. Similar concept, you're given a28 is 85.2, d is 1.7. Find that first term. So go ahead and work that out. Okay, so for this problem, you should find your first term is going to be 39.3 when you work it out. Alright, now this one, we want to write our arithmetic sequence again, but now we need to use that to find our indicated nth term. So here's our sequence, 7, 2, negative 3, negative 8. We want to find the 18th term. So we need to first write our equation. So we need to identify a1, which is 7, our common difference. I have to subtract by 5 to get each new term, so d is negative 5. So an equals a1 plus n minus 1 times d. So an equals 7 minus 5n plus 5. I'm going to shift the negative 5, and when I combine like terms, an equals negative 5n plus 12. So that's the equation for this sequence. You have to write that first. Now that I have my equation, I want a18. Well, that's replacing n with 18. So all we have to do is just replace n with 18. So we do negative 5 times 18, which is a negative 90. And negative 90 plus 12 is going to be a negative 78. So for these problems, you're already comfortable with writing the equation. After you write the equation, even more basic, you're plugging in the given n value to find whatever I'm looking for. Okay? Go ahead and take a look at this one again. You want, given that arithmetic sequence, find your 37th value for that sequence. So then pause the video while you work that one out. Alright, the equation you should have found by working this out is an is 1.2n plus 2. And when you plug in your 37 for n, because we're looking for the 37th term, you should find your 37th term to be 46.4. Alright, that's it for arithmetic sequences. I will see you next time when we start talking about writing equations of other types of lines.